Let's take a look at this example. This time we have combination of the voltage source, current source, and few resistors. But this time the circuit is a little bit different than the ones which we solved before. So what I would do in this case, first I have to check what I have to find. I have to find the current which goes through resistor R1. Please notice that the current which will go through resistor R1 is also my I total. Why this is my I total? Because this is the branch, right, which is connected directly to the ground over here, right, in this case. So the current is going to go over here, okay, and is going to go over here and will go over here. So total current I can measure at this point, right, in this branch or this branch. So what I'm going to do first I would convert the current source to the voltage source in order to make this problem a little bit simpler. This is my way to do it. So what I would do, I would simply find voltage source 2. Voltage source 2 is equal I source 2 times R2, where I source 2 is equal 5 milliamps times R2 1.2 kilo ohms. So voltage source 2 is equal 5 exponent 3 negative times 1.2 exponent 3. This is equal 6 volts. Okay, so this current source I can draw like this. This is my R2, okay, and because the arrow is pointing to the right, I would draw my voltage source like this. This is my voltage source 2. So now I'm supposed to replace this part of the circuit by this. Let's call this my point X and this is my point Y. So this is my point X and this is point Y. So I have to remove this part of the circuit, okay, remove it, and instead of this I have to put this. So now I'm going to redraw the circuit with the voltage source. Okay, so I have simply the voltage source over here. This is my R1, okay, and between point X and Y I'm going to draw the voltage source, or instead of current source I'm going to use the voltage source. So this is my R2 and this is my VS2 and this is my resistor R3 and this is my ground. Okay, so please notice that this is my voltage source 1, that this time we are dealing with the series circuit. Okay, so what I would do first, I would find V total. V total is going to be equal voltage source 1 plus voltage source 2. The question is why we add these two voltages together, because this is positive terminal, this is negative, this is positive. So when positive is connected to the negative means we have to add these two voltages together. So I'm going to have voltage source 1 is equal 10 volts and voltage source 2 we found this is equal 6 volts over here plus 6 volts, this is equal 16 volts. Next I would find the total resistance. R total is equal R1 plus R2 plus R3. I'm talking about this circuit right now. They are in series, R1 plus R2 plus R3. So R1 is equal 5 kilo ohms plus 1.2 kilo plus 47 kilo ohms. So our total is equal 5 exponent 3 plus 1.2 exponent 3 plus 47 exponent 3. This is equal 53.2 kilo ohms. Okay, so we found the total resistance. Now we can find the total current. I total, I'm talking about this circuit, I total is equal voltage total over R total, where V total is equal 16 volts over R total 53.2 kilo ohms. This is equal 16 volts divided by 53.2 exponent 3. This is equal 300.75 microamps. 300.75 microamps. This is my total current. We have to find P3. Please notice that we have to find P3. And remember, I said that total current is going to go through resistor R1, and the same current is going to go also to resistor R3. So we can say that we found at this moment current I1, and we found also current I3. So I'm going to write that my I total is also equal to I1, and this is also equal to I3. Okay, because these resistors are in series, so the same current is going to go through resistor R1 and resistor R3. So we found I1. Okay, we can say that I1 is found. Next, I supposed to find P3 because I have I3. So P3 is equal I3 to the second power times R3. I3 is equal 300.75 microamps to the second power times R3, which is equal 47 kilo ohms. This is equal, so we have 300.75 exponent 6 negative to the second power times 47 exponent 3. This is equal 4.25 milliwatts. 4.25 milliwatts. Okay, so this is my P3. Next, I'm supposed to find V2. In order to find V2, we have to get back to the original diagram. Okay, in order to get the correct answer, we're supposed to get back to the original diagram. So, in order to find V2, I'm supposed to find the current which goes through resistor R2. So please notice that we found I total. This current is always constant. It's 5 milliamps, and we're supposed to find this current. So, I total is equal I source 2 plus I2. This current plus this current is going to give me total current. Okay, so because this current must be equal the sum of these two, okay, and this current must be also equal to this one. That's why I have to write that I total is equal I source 2 plus I2. But this time I'm looking for I2. So you have to use algebra and simply find that I2 is equal I total minus I source 2. Okay, so I total, we found that I total is equal 300.75 microamps minus I source 2, which is equal 5 milliamps. Okay, so if I2 is equal 300.75 exponent 6 negative minus 5 exponent 3 negative. This is equal minus 7 minus 4.7 milliamps, minus 4.7 milliamps. Okay, so this is my current I2, the current which goes through resistor R2. So if I want to find V2 is equal I2 times R2, where I2 is equal negative 4.7 milliamps times R2, which is equal 1.2 kiloohms. Okay, so this is equal 4.7 negative exponent 3 negative times 1.2 exponent 3. This is equal negative 5.64 volts. Negative 5.64 volts. Okay, so this is the voltage. This is the voltage which I'm going to measure over here across resistor R2. Okay, so we found I1, we found V2, and we found P3, so we can say that the problem is solved.